And also welcome to the age of static analysis and automated refactoring, right? You can get the slides from the link on the screen. This link will also be in the final slides. So yeah, you get another chance. Yeah, so again, it starts with analyzing the title of the talk. What static analysis is something we are going to look into. Why do we call this a new age? And also, why is automated refactoring something else than what you can do with your IDE, which is already quite smart, but now, yeah, we need something else, apparently. Let's start with static analysis. It's mostly compared to, well, I would say human analysis, something that we did for years, just looking at the code and trying to figure out, is the right thing happening here? Do we call this method in the right way? Do we have the right types of arguments? And yeah, there's always this, question like, did we understand everything about the code? Did we get it all right? And yeah, of course, in practice, it's not enough to look at your code. And you also have to have some runtime checks about the types being used. Yeah, the code has been compiled by the PHP runtime. It already runs. And at some point, it turns out, well, the types are wrong. So we have been calling the method in a wrong way, expecting a variable of a different type. And we get a crash. Like in this example, we have a string argument for this function, and we call it with a number, an integer, and we get a runtime error, a fatal error, in fact. So that's not quite nice. Yeah, it says this is fine, but of course it's not really fine, but we have been doing this for years, or at least in the past, right? I started programming with PHP in 2002, and yeah, back then there was not really a lot to do about this kind of issue. So yeah, you had to be lucky in a way, and you sometimes get this white screen on a PHP website. So we are now in a much better situation where we can use static analysis tools like PHP Stan. In fact, Psalm was there first, and there were some other tools less famous. But yeah, I'm in the PHP Stan camp. I don't know why, it just happened like that. But I'm using this program to statically analyze my code, so I don't have to look at all the code and check, like in my brain, if the types are correct. A tool like this does this analysis for you, and it shows an error if anything may be wrong, may become a runtime error. So yeah, what's the difference? It's all just about looking at your code and trying to interpret what's going on. Is everything correct? Well, of course, the human analysis part is really about looking and trying to understand, but the computer can be much more accurate at this and much faster as well. And of course, the tool can just read your entire code base and try to understand everything when used together. So it's not just the code in the merge request that it's being analyzed, it's your entire code base at once, which is also why it takes some time sometimes to analyze everything. A static analysis tool will read your code, and it's very important for it not to run your code because that may have some side effects. For this, there was a whole new reflection library created, the static reflection, that yeah, does not really load the PHP file. It just looks at the PHP file and then tries to understand it. The static analysis tool, like PHP Stan, will also reason about the code, what's going on in this code line by line, and it will try to find all the reasons that any of this code may fail when it's actually being run. And then it returns or reports any error to your screen. This kind of replaces the compile time checks that many compiled languages have, but interpreted languages like PHP has this special situation where, yeah, we have to look at the code before we run it to find out what could go wrong. So instead of a runtime error, we get a nice error that says, on line 7, you have this parameter, and it's supposed to be provided with a string argument, but you are giving it an integer argument. So yeah, very nice. And you can imagine we are catching errors very early on. Just when we wrote the code, we run PHP Stan, and we get this error on our screen. Instead of the user is already using our website and invoking this code, and then gets a runtime error. So that's really quite nice. Some simple examples that can be done with PHP Stan. You can look at method calls and say, oh, you're missing an argument. you are supposed to give me 3 arguments, but you are giving 2. I don't know, something like that. And it may be a very silly thing, but this is very useful if you are refactoring. You are introducing a new required argument, and that's the way I like to do it. So I'm just adding the argument, and then I run PHP stan, and it will tell me all the cases where it's wrong. So quite nice. It will tell you about argument types, of course, return types being incorrect, methods that cannot be found, classes that don't exist, all of that stuff. So it really helps a lot if you are refactoring your code and you don't have tests. And I mean, well, you all have tests for sure, but for some parts, maybe not. And then static analysis is a great, it's catching a lot of errors for you. But it's interesting to note that we already have, like I guess most of you are using an IDE that is smart and can also understand your code and give you lots of information about, is the code correct? It has these squiggly lines and like colors being used to show, is this correct? And you could say yes, so I don't need PHP stan, I have a nice IDE that gives me all the errors, right? So yeah, I like to point out a few differences there. It could be still that coworkers are using different IDEs than you are. I mean, you are using the right IDE for sure, but others may not be using it. And well, there's always a matter of taste there, so people will disable some rules. They will consider it optional to remove all the problems from the code. So there's no reason that, that you can trust the code being committed from an IDE. And even though the IDE has some good checks, well, you don't really know if the programmer has had them turned on or has actually dealt with the errors. So the IDE doesn't really prevent bad code from being merged. I mean, there is still a similar feature where you can say, for instance, in PHP Storm, like you have to fix all the inspection errors before committing or something or pushing. But you can also turn that off. So it's really very optional. So in the end, what we want is to have a tool that runs as part of our pipeline. Well, maybe we can use the IDE to run in the pipeline, but PHP stan, in fact, is very nice. You can have this run in the pipeline, check all your code, and the configuration for PHP stan, when used as part of the build pipeline, is going to be the same for everyone. So all the rules that you want to be enforced in your project are definitely going to be checked as part of that. So that's very nice. PHP stan and other tools will read all the files in your project. They have a set of enabled rules for your project, and for these rules it reports the errors. Finally, it will display the errors, and maybe, well, one of the most powerful aspects of it is it exits with 0 or non-zero exit codes. 0 meaning everything is fine, non-zero meaning there are errors, and this will actually block the pipeline. So it will say, well, the project failed at this point, or the build failed at this point, so don't continue, don't merge this. Yeah, so the first step is reading the PHP code. It's parsing the PHP code. What is parsing? I don't know. It's understanding, it's trying to make sense of the code. It's also what a language runtime does, like PHP. When it understands your code and tries to run it, it has to interpret it first. So it has to understand what is in these PHP files, and it then converts it to machine code to execute. But, well, if we want to analyze the code, it's enough for us to just have access to all the parts. So we understand the code and have it in memory as objects. This allows us to do, well, some kind of meta-programming. So we program and think about the things that we find in our code. So as an example, we can analyze a file which consists of some declare statements, maybe some use statements. Then we have class definitions, and in the class definitions we have method definitions, property definitions, and within the methods we have statements. So all of these become the abstract syntax tree, as it's called, for a parsed bit of code. And these are actually objects in memory. So we will have a file object, we will have a class object, you know, a method object. So all of these can be looked at, can be inspected, and we can interpret them and say, well, something is wrong here. We have a use statement that is not used somewhere in the statements. So that can be removed. So all of these things can be analyzed in memory, and this is in fact what a tool like PHP-Stan does for us. It does this by taking the abstract syntax tree, so the whole tree of nodes, and it looks at all of the nodes in the file, and looks at the children of those nodes and the children of those nodes, and then it runs a bit of code for all of these nodes. So there are some rules, things that are allowed to look at the code, look at the node, and say this is wrong. Another example of something that you can do with node traversing is calculating cyclomatic complexity. You just look at all the if statements, the for eaches, and for every one of those do a +1, and you will get a score for the complexity of your class. So just an example of static analysis where you go through the code, understand what's going on, and have some verdict about that. PHP-Stan's special ability is to understand types. I mean, that's the big power that it has. It collects information about types from any place. It also looks at your vendor code, and it tries to read through the code and find out what is the exact type of a variable. And it's very smart at this. I'll just give a very concrete example. But then it runs some rules providing the type information to those rules. So the rule knows exactly what type a certain variable is at what point in the code. So as an example, here is a bit of code. In the beginning, here you can just see when you assign variable a, then a is an integer for sure. If you assign a string to it, the type changes to a string. So I mean, that's what's allowed in PHP, but PHP-Stan actually keeps track line by line of what the types of the variables are at this moment. Within the function, we have a string or null argument. So when we enter the function, we know that this bar variable is either null or a string. So PHP-Stan knows this and keeps track of this. Then if we have an if clause where we check for bar is the same as null, then we can be sure that bar is no longer a string, it's definitely null. So whatever happens with bar, and if we call a function that expects a string, then, well, we get an error. It says, okay, no, we cannot call it with null. And outside the if, I mean, based on the return statement that's inside the if, we know that bar is a string. And this is basically the way that we are also reasoning about the code if we do like the human analysis, where we just try to understand, oh, what is the type now? What's in the variable now? And PHP-Stan does this for us and for our entire code base. So that's quite nice. So if you already have some experience with PHP-Stan, you know that there are many rules and many rule levels, and it will give you a lot of errors. Yeah, sometimes thousands of errors, if you like. So that's a bit of a problem, but of course there are ways to navigate around that. You can ignore all the errors, interesting idea, or you can work your way up from level 0 to 1, etc., to level max. Maybe we can talk about that later. But when talking about code and correctness of your code, there are still problems that will go unnoticed because PHP-Stan doesn't know your project or doesn't know your style, doesn't know the rules that you want to apply in your project. So for instance, if you look at a code review and say, maybe you should inject this dependency as a constructor argument instead of fetching it from some global static thing. Okay, well, that's a nice thing, but can PHP-Stan recognize this? Well, not on its own, so you have to help it with that. Well, this class should be marked as final. It's something that some would prefer, but it would not be nice if PHP-Stan would say this. I think it would. You will get into trouble if you propose such a thing. So if you want it, you have to create your own rule for that. It's like it's maybe a controversial thing, right? You don't have to put it into a package. Return early is something, well, it could be a matter of taste. Like, it definitely is going to be very, it improves the code, but need to discuss about it. Maybe you want arguments to never have a default value, right? Could be, I think it's a good idea to not to have that, but, could be depending on your team style. So, yeah, there are a lot of things about code that we could say just by analyzing it, thereby, well, removing the need to ever point it out again. And I think it's very useful to do that. And in fact, that would be like using PHP Stan sort of next level. You can create your own rules for it, right? A good source is code reviews indeed, or discussions if you're talking with colleagues, or if you're in those mob or pair programming sessions, and you realize, this is actually a rule that we have in our team that is not verified during our build pipeline. So it's really up to this person to point out this rule, whether or not it will be applied. And I find that really interesting, to try to push all those rules into the CI in some way, the pipeline. An example is, you should really use datetime immutable, right, instead of datetime. I'm not sure, it's a bit of an outdated example maybe, but there are lots of code bases that are still using datetime for sure. So yeah, it could be that we have to point that out to new members of our team, for instance. Another thing could be that a to-do comment is not allowed, right, unless you have a ticket number in it. Okay, that could be like a team rule. Or we never inject the container as a dependency. Nice example as well. Or maybe we only inject it into controllers. I don't know what your rule is. Could be nice. So all of these rules are really about the code. And if we have access to the AST, we can actually inspect the code and find out if the rule applies. And we can provide an error if something is not right about the code. So PHP Stan definitely allows to create custom rules. It's a very useful thing to do. It also allows it to do in a TDD fashion. So we start with a nice simple test and then expand with multiple edge cases that we also need to cover. So we can really build a rule in a very simple way. And it's a lot of fun as well to reason and to think about and to work with the code in this abstract syntax tree, like the objects that represent the code. So as an example for the container rule, we could say that, we have to register a PHP Stan rule for class method nodes. So whenever we find a class method, which is just a method, right? And then the name of the method is __ construct, which is the name of the constructor, right? Then we check for every parameter, is the type of the parameter container? And if so, then we report an error, right? So it's actually a recipe, and it's very simple to do this with PHP Stan. So I really recommend looking into that. If you're already using PHP Stan, try to find some team rules that you have, some coding guidelines that you can fit into this structure. What's really nice is that you don't have to think about and have the discipline to always point out the issues in the code that is committed by your team members. I mean, you don't make those mistakes anyway, but you have to always point them out for other people. So yeah, you don't want that anymore. You can just use the tool, use the static analyzer to do that, which now becomes more or less a team member, a very experienced one that can also point out what is wrong about the code. People can learn from the static analyzer, like how to do this in a better way. They become a team member, and you can make very friendly messages. You can also read more about these links to the messages. So yeah, it can become a learning tool for the team. And now the code review is actually more interesting to do because you don't have to point out all those annoying parts that you have to repeat again and again. And it's the same as with when we started to use code formatter tools, right? Before that, we always had to point out like, okay, this accolade should be on the next line, and then we have 4 spaces or 2 or tabs or whatever. And now that you have the tools, no need to discuss this anymore. So you can reach the next level of design discussions. And I think that's more interesting than all those silly rules. Just as an example, if you find a bug that is very time consuming in your project, something like this, which took me some time to find out. I had a command and then like a Symfony command. I was using a helper for that, the question helper. I don't know if you know this, but I was trying to do it properly, sort of setting it in the constructor and adding a helper to it. Well, that doesn't work because inside the constructor, the get helper is not returning anything useful, or in fact, it was. I don't know what it did, but the question helper wasn't there. So and it was really hard to figure out. And at this point, we can realize, if it takes me an hour or so to figure this out, then yeah, probably somebody else is also going to run into this problem at some point. So what you do is you create a PHP stand rule. Once you have some experience, it's very easy. You look at, it's like an event subscriber, so you say, I'm interested in method calls. That's the first part. And then the process node function is invoked for method call nodes. And you have to look at it like, is the name, in this case, it's not a dynamic method call. Is the name getHelper? And then we check for what function is, where is this function being used? It turns out, well, you can use getHelper in something else than a command class. It's like an edge case. All of these are edge cases. It can be used outside the constructor, so then it's perfectly fine. And yeah, in the last line, we know for sure that getHelper is called inside the constructor of a command class, right? So once we have all those edge cases covered, we can set up a rule error that says getHelper should not be called in the constructor. And it's going to save some time. It's going to really help some people to just quickly go ahead and learn about this in a very friendly, very easy way. Just as an example. You can also make the static analyzer a lot smarter, although it's already very smart, but there are some things that we are doing as PHP developers sometimes that are quite magical, and you don't know what a return type, for instance, is of a thing. So then PHP stand says, well, at least we have to say it's mixed. Yeah, okay, but mixed can be everything, so it's not very useful. Whereas, for instance, if we are calling container get event dispatcher class, then we know that the result should be an instance of event dispatcher. Could be a subclass, but yeah, at least we assume it to be. So yeah, we can actually create an extension for PHP stand that helps us understand what's going on, and we'll say when you call get with a class name, then you will get an object of this type. They're very easy to do, in fact. Same for command bus handle new signup command. Yeah, if you do this, you will get the return value of the signup handler. Okay, it's a convention, and you don't know for sure, but we can assume that it will work like this. So for the reading, I have this book, Recipes for Decoupling, which shows a lot of PHP stand examples, like custom rules for things like this. So we don't want to inject the container. Oh, am I doing this? Yeah, I guess I'm doing it. Nice. Yeah. So yeah, some really like everyday examples of how to decouple, but then with a PHP stand rule. So that's like we don't want to provide entities to templates as an example. So that could be interesting. But if you don't want to buy anything, of course, like this is not a commercial, you can also go to the PHP stand website, and you can find more information about custom rules there. Anyway, we have lots of custom rules out there in community packages as well, also for Symfony and Laravel and things like that. So, all right, so in practice, you may have this issue of too many errors. That could become a problem. How to deal with that? Well, yeah, it's a matter of, I think, facing the issue. Yeah, you have technical debt in your project, and yeah, you have to fix it. So it's a really good idea to start fixing the errors. In my experience, it's really nice to well, first ignore everything and then set level max for PHP stand. It will be a tough learning experience, but yeah, from now on, every new code that you write will at least be perfect. But then you need to have some kind of an initiative that cleans up all the warnings. So you have to spend some time every week, preferably, to fix a number of errors, number of warnings. Fun thing is that many errors will be shown multiple times for the same issue. So sometimes you fix one problem, and then multiple issues or errors disappear. So that's quite nice. But yeah, it takes some effort. But yeah, in my experience, it's really nice to just turn on the light and to say, okay, we are not going to ignore everything. We are facing all the problems, and we are steadily increasing like reducing the number of errors, increasing safety, increasing type coverage. So type coverage, I mean, that's a new word, right? How well described are your variables everywhere and your method calls? So yeah, that's interesting. But yeah, it shows all the work that we need to do. Well, now we just need to do it. And I find that once we have static analysis in our project and we are looking into all of the issues, we are just realizing how many potential issues were there in our project and how many errors we can now start preventing. Yeah, we can even go much further. Like, well, as I mentioned, we started formatting the code in some automated way. We got a nice IDE that helped us with lots of things and find usages and move and rename. Then we get PHP Stan, which gives us so much more insight into the code. But now we also have Rector, which is based on PHP Stan. And yeah, it goes even further. So it will actually help us do automated refactoring for us. It was created by Tomasz initially. You can go to getrector.com to read more about the project and to install it. It's very easy to get started. But first, like, what is automated refactoring? Maybe that's good to explain first. So I mentioned the datetime rule, where, well, you have in your team this rule: we don't want to use datetime, we want to use datetime immutable. Okay, it makes a lot of sense for us PHP developers. We can write a static analysis rule for this. And the result would be that every time you use datetime, you get an error that prevents merging. But this is quite a simple problem, right? We just would look at our code and sort of replace all the datetime usages with datetime immutable, like whenever new is used in front of that. So yeah, it is quite silly. And while we are actually already inside the AST, like the abstract syntax tree, we can already look at the code and find out all of the nodes that are using datetime. And then, well, we might as well just modify them, right? So that's what the traversal revisited means. With Rector, it does the same thing as PHP Stan does. So it loads all of the stuff in your PHP project, puts it into memory, and then allows rules to transform the nodes. So not just look at the nodes and produce errors, but you can actually modify the nodes in ways that make them better. So then in the end, you only need to take the tree and do like a toString, and then, yeah, put it back into the PHP file. And this is a really simple idea, but it's extremely powerful. You can do anything in the tree. And yeah, if you have some experience with Rector, you know all the possibilities already. But maybe it starts with the very simple example of whenever we see a datetime class being used, we can just replace it with datetime immutable. But then we also have to think about all the edge cases. So it's not just about new datetime, but it's also about parameter types that use datetime. It's also about return types that use it, property types that are there that already use datetime. And it turns out that many of these use cases, whenever you feel the need to change a node in some way, already has, it's not a rule, it's a rector. So in this project, there are many rector classes that can be used right away for your refactorings. So in this case, the rename class rector, it's not really a clear name. It's not like renaming the classes, but whenever you use the class, it's changing it to using the other class. So this already works for you. And yeah, after having worked with Tomasz for a while, I realized that, okay, turns out a lot more is possible here. So this is like the flow diagram. I have an idea for a rule, something like, indeed, we should not have the container being used, we should inject the service directly, things like that. So the question is, can you automatically create an error based on just the AST? So if I can understand the code, can I make an error for that? Well, maybe the initial answer is no. But then, are you sure? Maybe discuss it with some people in the community, and you realize, oh, it could actually become a rule. Well, still, sometimes it is not possible, but that's really very sometimes. So then, in that case, you have to check things manually. But many of these things that are about the code that would happen in a code review, and you would say, no, it should be like this. That's our team rule. That can really become a static analysis rule. But next level would be to consider, can it also become a rector rule itself? So can we make it so that it's not just an error showing what's wrong, but it can also fix what is wrong for you? And this is usually when there is a very simple recipe that you can also follow like more or less mechanically in your mind. If you can think of the recipe, then you can also write it in Rector code. So that's really nice. Then you create the automated refactoring rule. If not, if it's a problem that needs thinking from a human, like how to solve this problem, then you can write the static analysis rule. So really a lot is possible there. And yeah, I mean, there are some examples. Rector can use that return early idea and improve your code like that. There are ways to find final classes or like finalizable classes, classes that have no subclasses. Then it can automatically make it final. It can look for dead code, find things that are never used and just remove that code for you. Scopes can be reduced or, yeah, I think mostly reduced indeed. And there is just a lot more, right? When you go down the rabbit hole using analysis, but also refactoring, then I find it has two major effects. First, well, I wasn't aware that the code could be written in a better way than I wrote it. This happens in particular with new PHP versions or new framework versions. Rector will just point out to you that instead of doing strupos is the same as 0, and then you can also just use string starts with or string contains or things like that. So like any of those things that are new for a language will be automatically applied for you. So that's funny. You can learn from that. You don't have to follow the news on php.net. You can just yeah, let Rector tell you. And again, it turns out that Rector also becomes like a team member that you can learn from. Also, I found that, and this was also when working with Tomasz, it's really interesting. Rector was trying to change my code in all kinds of ways, and then he also had the easy coding standard, like the code formatter enabled with with lots of rules that, well, I personally didn't really like a lot, but yeah, I just let it happen. I wrote my code, and then everything changed, and I was like, yeah, okay, if it still works, it's fine. It doesn't really matter anymore what it looks like, almost. It's, yeah, I mean, in most cases, it was better, of course. In some cases, I had to let go of some favorite ways of writing code, but it's more about the functioning of the code, and of course, can I understand it? That's important. But yeah, where things are exactly on the page, well, I don't care that much. I just give it all to the code style fixer and the automated refactoring tool. Yeah, so yeah, I would say everything is great at that point. And again, some further reading, you can find information on the website about how to create your own Rector. And also there is a book Tomasz and I wrote together on how to create your custom rules, but also how to make Rector part of your team, have it actually modify code in your pipeline. So that's interesting. Instead of throwing errors, it would be quite nice if it would just change your code for you in a better way and just add a commit, right? Could be nice. So there are some examples there. Finally, why would I call this an age, like a new age for PHP developers? I think, yeah, I somehow had feelings that were quite similar to when Composer arrived in 2012. It changed everything, and we were thinking about class autoloading and you know, a standard for where to put things, sharing code in packages, much better than what was before. It really changed the way we write PHP, and I think for static analysis, it's really the same thing. We can clearly see that there is a limited way of adding types, type things, type aspects to the runtime of PHP itself. And we can go a lot faster if we are just using type annotations and tools like PHP stand to understand what's going on and to help us, for instance, implement generics, which was not possible or would not have been possible for PHP runtime itself because it will be, in fact, it will be too slow. So if we do all the type checks at runtime, well, PHP itself will become very slow. If we do it at analysis time or our compile time, then yeah, we can do whatever we want. No user will be impacted by that. So automated refactoring is like the next step for that. I think for some it can still be a bit scary. It may be used and useful for upgrading to newer PHP versions or libraries or frameworks. But yeah, I really recommend you to try it with a simple rule. Just get started with 1 or 2 rules, not too much, and yeah, use it to get out of legacy land and to add actually a very smart team member to your team. Keep an eye on both Tomasz and Andre, who is the maintainer of PHP Stan. There are some blogs for that, so yeah, it's really recommended reading. Keep an eye on these blogs, because this is like the bleeding edge stuff for PHP developers. There are some like advanced PHP Stan usages, like adding more rules, adding more type checks, things like dealing with code bases that don't have PSR4 for all the namespaces yet. There are ways of downgrading your PHP, so you can write PHP in the latest version, and then when you release the code, you first downgrade it to the version that you need to support. There's now like type resolving for regex matches in PHP Stan. It's just amazing, and a lot of performance improvements as well recently. So yeah, just keep an eye on those blogs, and yeah, be amazed at what's possible these days. Yeah. Nice. So that's the final slide. We have some time for questions or comments, I think. Please leave some feedback, and you can again download the slides there. Thank
you. Thanks for the presentation. I would like to know if you run Rector in the CI to make sure. It seems there are more rules in Rector than in PHP Stan. So do you run it in the CI?
Yeah. So I have a set of scripts that I run on the computer before committing, and then the CI pipeline also runs the tools, but it doesn't fix, like it doesn't change the code. It will just say, I would have changed this code, and then blocks the pipeline. So it says, yeah, you should run it first on your computer.
Okay.
Yeah, but that's the example I mentioned. You can also have Rector just make a commit for you. So that's possible with, for instance, GitHub Actions.
Hello. I was just wondering if you know if it is possible to automatically or easily turn a PHP Stan custom rule to a Rector custom rule?
That's a good point. So the code is quite similar. It still uses mostly PHP parser / PHP Stan node classes. So the ingredients will be there. And also like the structure of the rules is quite the same. Like you say what node you're interested in, and then for PHP Stan you process it and give an error. For Rector you would process it and change the node and return the modified node. I don't know of a tool that can transform, in a sense, this code, but it will be very similar. Yeah, it's a really very similar code. But maybe it's a good idea to get started with trying to implement a PHP Stan rule, and then, if you like, you can also modify it and turn it into a Rector rule. Yeah. Okay.
Thank you, Matthias.
Yeah, thank you. Goodbye.